Consider the line segment AB that we have on our graph. Let's go ahead and create ordered pairs for those points. So I want to know the ordered pair for that particular point. So I'm going to write in that A is -2, 1. I'm going to write in that B is 4, 1. So we notice that the y coordinates in both ordered pairs are the same. The difference seems to be in the x coordinates. Now, let's zoom out for a second, and let's think about the process that we would go through to try and figure out what the midpoint of that line would be. The first step is going to be able to try and find the distance between the points A and B. And that's pretty simple to do. All I have to say is 4 minus -2, and that gets me out 6. So this means I have a distance of 6. Now I have two choices. I can look at this -2 here, and I can say -2 plus 1/2, and I'm writing 1/2 because I'm talking about the point that's halfway in between A and B, and I can multiply that by 6. That's going to get me -2 plus 3. It's going to get me +1. The other way that I can think about that, I'm going to indicate this way in green, is that I could look at the fact that I have 4 here, and I could say 4 minus, since we're going to the left, okay, so I have 4 minus 1/2 times 6. That would get me 4 minus 3, and that would also get me 1. So what I've recognized is the point halfway between A and B is going to be, let's see, 1, from this one to this one, comma 1. The second one came from the fact that the y coordinate is going to stay the same no matter what point is along the line A and B. So our steps were to find the distance between A and B. We found out that that was 6. And then we were either going to take our x coordinate for A and add 1/2 times 6 since we were going to the right, or we were going to take our x coordinate for B and subtract 1/2 minus 6 since we were going to the left. But this problem is simple for two reasons. First of all, we have a horizontal line. It's only going left and right, it's not going up and down at all. Secondly, we were talking about the fact that we're looking at for the midpoint, the point that's halfway between A and B. But what if we want the point that's 3/4 of the way between A and B, or maybe 1/10 of the way between A and B? That's when the situation is going to get more complicated. Let's look at that on our next slide. So at this point we want to be able to find the distance between point A and point B. So let's go ahead and write out what those are. First, A looks like it's at -2, comma -2. Then we're going to look at B, and it looks like that's at 4, comma 6. This problem is going to be a bit more complicated in the sense that now we're talking about a line that goes left and right as well as up and down. It goes horizontally as well as vertically. Also, we're going to try and find some new point that's right here, roughly 1/4 of the way between A and B. But we can't just look at the graph and figure out what that point is. We actually need a process to get there. So let's call that new point that we're looking for point P. And let's remember that that's some x and some y. Okay, let's look at this and zoom out just for 1 second. So I'm just going to take my entire screen and sort of zoom out. Now we need to think about this in terms of two problems. First we're going to find our x, and then we're going to find our y. So let's sort of draw a line down here and separate this into two different tasks. So my first task is to find x. I think I'm going to do that maybe in purple. Okay? So let's think about the distance between A and between B. So if we're doing that, we need to think about the horizontal distance first, since we're trying to find x. So what's the difference between 4 and negative 2? Let's write that out. So let's do 4 minus negative 2, same as 4 plus 2. That's going to get us to 6. Now I really have a choice in how I want to proceed. I could do negative 2, and I'm getting that negative 2 from this x coordinate of A, and I could add plus 1/4, since I'm going 1/4 of the total distance of B to the right, plus 1/4 times 6th. My other option is to look at the x coordinate of B, which is 4. And I can go ahead and write that down. I can do 4. Since I'm going to the left on my graph, I can go ahead and I need to realize that I need to put in a subtraction sign. The question is, should I use 1/4 again? And in reality, I shouldn't. If I'm going from B down to this new point, I'm talking about going 3/4 of the way from B to A. Whereas when I was here, I was talking about going 1/4 of the way from A to B. So instead of subtracting minus 1/4 times 6, I actually need to do minus 3/4 times 6. If I do this by hand, or if I decide to do it in a calculator, I'll realize that for both of these values, I'm going to get negative 1/2 and negative 1/2. And that should tell us that either way, whether I use this method, whether I'm going from A to B, or whether I'm going from B to A, I'll get the same answer either way. So you can choose if you want to do it that way, or if you want to do it that way. So getting back to the original problem, I found my answer, at least for the x value. I found that x is negative 1/2. So now we want to talk about the second part of our problem, which we're going to do in blue. So we've thought about what happens when we go from left to right, because in this total distance going from A and B, we're really doing a motion where we're going from left to right, and we're also doing a motion where we're going up and down. So when we're talking about x, we're talking about the left and right part. Now I want to talk about the up and the down part. So here we found the difference between our x coordinates. Oops, my bad. Found the difference between our x coordinates. Now we're going to try and find the difference between our y coordinates. And that's just some pretty simple arithmetic. We can look at 6 minus negative 2, and we'll get out 8. In the same way that we had two choices in the x part of the problem, we will also have two choices in the y part. So let's first do this option. Let's look at negative 2, and let's write out negative 2 plus 1/4 times 8. Okay, now let's think about our second option. We can look at that 6, and then we can do, since we're going to the left now, we could do 6 minus 3/4, and then we can do times 8. We'll find that in this case and in that case we get the same answer. And that answer is going to be 0. You don't have to do it both ways, as in you could choose either to do this line or you could do this line in your problem, but doing both will help you check. So, since we found 0, we're going to go ahead and write that into our final answer. So we know that whatever point that we're working with, I'm going to use orange now, or something orange-like anyway. is roughly here at -1/2, comma 0. And we were able to do mathematics at the bottom of our screen to justify that process. So I'm not going to show you another example of this, but I do want to look at this same example, but just quickly in a different way. I think I have a strategy that might help you solve problems similar to this one. Let's go on to the next slide. In this final slide, I want to show you a more geometric way of looking at this problem. Now, I'm going to be drawing some of my own lines, so forgive the sloppiness. But remember that when we're thinking about a line that is going both up and down and left and right, we can break it into components where we're talking about the left and right part and the up and down part. So let's go ahead and do that. So let's draw a line that represents the left and right part. I'm going to do that in purple. So here's my purple line. I think I want to make that a bit thicker. So let's go ahead and erase that. And let's put in a line that we can see a little bit better. Okay, so now we're talking about a line that goes left and right. And we also want to be able to draw in a line that goes up and down. I think I'm going to do that one in blue. So now I'm drawing a line that goes up and down. So really, if I want to think about the points, that is a quarter of the way between this point and that point, talking specifically about this one, I can first find this point here, which represents 1/4 of the horizontal distance from here to here. In other words, this point, I'll go ahead and draw it in, this point represents about 1/4 of the horizontal distance from this point A to this point, I think I'm going to call it maybe D. Okay, now let's think about another way we can think about the up and down component. So with the up and down component, we're also talking about 1/4 of the distance from D to this point B. So what we're actually talking about is this point right here. So the idea is, if you're struggling with the mathematics of what we did on the previous slide where we did all of our calculations, you can also think about this geometrically, where we take a line that goes up and down and we break it into two lines. One that goes, oops, didn't mean to do that, one that goes left and right, and one that goes up and down. Then we find the point that is a quarter of the way between A and D, and a quarter of the way between D and B. So it becomes more of a geometric problem than an algebra problem. Okay, that concludes this video. The purpose of this video is to be able to break lines into segments and have both a mathematical and algebraic and a geometric way of doing that. At this point, you should be able to be given a line that goes horizontal, vertical, or that is slanted. And if we say that we want a point that's 3/4 of the way between A and B, or 1/2 of the way between A and B, or even 7/8 of the way between A and B, we should be able to have two methods for doing that.